Hello, this is Rikka, a learning guide for electrical workshops. Today's lesson covers the basic PLC time chart process. Understand the PLC ladder configuration and test through the simulator. Then, enter the corresponding PLC ladder into Arduino to see if it operates normally. On the right side of the screen, there are input-output parts for each PLC. There are 6 inputs and 5 outputs. Each configuration is described above. First of all, start each electrical connection of the LITSA simulator. Let's look at each configuration of the ladder through the PLC editor. PLC ladder configuration is explained. Priority is given to output before starting the PLC. Therefore, the lamps PLA, PLB, and PLC are all on. Depending on the input type of each selector switch SSA, SSB, SSC, the lamps PLA, PLB, and PLC turn off and then turn on again according to the given time. Depending on the 3 inputs, each given lamp turns on and off differently. First, according to the selector SSA, falling edge, it is connected to the internal relay M0 coil, which again creates a self-holding state. The operation configuration by the selector SSA operates the timer T0 below, and the timer T0 operates for 3 seconds. Timer T0, connected to internal relay M3 for 1 second, M4 for 2 seconds, and M5 for 3 seconds. The internal relays M3, M4, and M5 are connected to the output lamp PLA, PLB, and PLC at the bottom, respectively. I'll check the output part again and check it out. Next, according to the selector SSB, falling edge, it is connected to the internal relay M1 coil, which again creates a self-holding state. The operation configuration by the selector SSB operates the timer T1 below, and the timer T1 operates for 3 seconds. Timer T1, connected to internal relay M6 for 1 second, M7 for 2 seconds, and M8 for 3 seconds. The internal relays M6, M7, and M8 are connected to the output lamp PLA, PLB, and PLC at the bottom, respectively. I'll check the output part again and check it out. Finally, let's look at the selector SSC input. In the state of selector switch SSC rising edge, it is self-maintained by internal relay M2. Timer T2 is started by internal relay M2 and operates for 4 seconds. Up to 2 seconds is connected to internal relay M9 and up to 4 seconds is connected to M10. M9 is connected to lamp PLA. PLC and M10 is connected to PLB. Now let's look at the output part lamp. There are internal relays M3, M4, and M5 that process the lamp operation by SSA and connect to B contact because the purpose is to turn off the already lit lamp. And by SSB, ramp operation is connected to M8, M7, M6, and by SSC, ramp operation is connected to M9, M10, M9. The operation configuration for each selector is tied together and connected to each lamp PLA, PLB, and PLC. Now, let's look at each of the internal relays in order to prioritize the 3 operation patterns as input first. There are SSA self-holding relay M0, SSB self-holding relay M1, and SSC self-holding relay M2. In SSA, the other pattern side relays, M1 and M2, are connected in SSB, the other pattern side relays, M0 and M2, are connected in SSC, the other pattern side relays, M0 and M1, are applied. Now, after explaining the PLC ladder, let's take a look at the operation configuration through the Rikka simulator. And finally, let's input it into Arduino and actually look at the result through processing.
Input on. Wiring breaker. Input on. SSA. Input off. SSA. Input on. SSB. Input off. SSB. Input on. SSC. Input off. SSC. Input on. SSB. Input off. SSB. Input on. SSA. Input off. SSA. Input on. SSC. Input off. SSC. Input on. SSA. Input off. SSA. Input on. SSB. Input off. SSB. Input on. SSC. Input off. SSC. Input off. Wiring breaker.
World of Rikka. Thanks for watching. Please refer to learning. Subscribe check.